morning everyone. Now I am going to discuss a problem on analytic function that is nothing but it is a continuous and it satisfies the Cauchy Riemann equations. Here the function can be defined in different form, and that is a continuous function or not in other values of 0 and at particular origin is it continuous. Okay, the function can be defined at origin is one way, in non-origin is another function. That such type of the functions can be expressed in two ways, means at origin the function will be 0 and at the non-origin points the function is expressed in the other way. Okay, in such cases the function is continuous and is it satisfies the Cauchy Riemann equations and is it derivable at particular point of origin. Such solutions are involved in this problem. But here the function is defined in two types, especially at origin is one type of the function, in non-origin case that is expressed in other case. Means first we have to show that the continuous means if the function z is tends to 0, the z function is involved in x and y variables, means we can take the order is change in the first case and second case. In two cases the limit values are same and then the function is continuous. And also the function is in continuous or not in the third case, that is the simultaneous x and y variables are expressed and both are tends to 0 simultaneously along the path y equal to mx. In such a case the limit value is the same, then that is a continuous function. If the limit value is changed, then that is not a continuous function. In this case, how we can solve the function is continuous or not and it satisfies the Cauchy Riemann equations or not. Okay, it is very important problem and it is a repeated question. I am taking the problem and this can be asking which way, that is prove that the function f of z defined by the function f of z defined by f of z equal to set of x cube into 1 plus I minus y cube into 1 minus I by x square plus y square at z is not equal to 0. It is 0 at z equal to 0. We can show that is it continuous, is continuous and Cauchy Riemann equations are satisfied or satisfied at the origin yet f dash of 0 does not exist. Here prove that the function f of z defined by f of z is equal to x cube of 1 plus I minus y cube of 1 minus I by x square plus y square at particular point, non-zero point, that is nothing but at every point of z except origin. If at origin the function is 0, okay, then here we can prove that this f of z is continuous and it satisfies the Riemann equations at particular point origin, and the derivative of the function at origin is does not exist. Okay, here first we can take, is it continuous or not? Okay, let f of z is equal to x cube into 1 plus I minus y cube into 1 minus I by x square plus y square at z is not equal to 0, and f of z is equal to 0 at z equal to 0. Okay, clearly at z equal to 0 the function is 0. Here we can take the f of z naught is origin, that is 0. Okay, we can take if the limit of the function as z tends to 0, is it equal to f of z naught or not? If when z is equal to 0, the function is 0 means indirectly they have given f of z naught is equal to 0. Okay, here take limit z tends to 0, f of z is equal to limit z is involved x and y variables, so x tends to 0, y tends to 0, x cube into 1 plus I minus y cube into 1 minus I by x square plus y square. Okay, here first we can take x0 limit, then y tends to 0, it is 0 minus y cube into 1 minus I by 0 plus y square, that is nothing but this y square, y get cancelled. Next we can apply y limit, then it will be 0. Okay, if 0 into something is 0. So here the first case, limit z tends to 0 f of z means first we can take x tends to 0, y tends to 0, it is equal to f of z naught, that is where z naught is equal to 0. Okay, the second case, limit z tends to 0, f of z is equal to limit y tends to 0, x tends to 0, f of z is x cube into 1 plus I minus y cube into 1 minus I by x square plus y square. Here first we can apply the y limit, that is equal to limit x tends to 0, x cube into 1 plus I minus 0 by x square plus 0. Then x square get cancelled. Here it is equal to apply x limit, it is 0, that is f of z naught, where z naught is equal to 0. Therefore f of z is continuous as limits x tends to 0, y tends to 0 and y tends to 0, x tends to 0. Next we can take, now take x and y tends to 0 simultaneously along the path y equal to mx. Then that y is substitute in the limit z tends to 0, f of z is equal to y is depends on x means the limit value only for x, y is replaced with mx. So x cube into 1 plus I minus m cube x cube into 1 minus I by x square plus m square x square. In the numerator, taking common x cube 1 plus I into minus m cube 1 minus I by x square into 1 plus m square. This x square get cancelled. Now we apply x limit. In the numerator x is there, then this limit value is equal to 0. It is equal to f of z naught, where z naught equal to 0. Therefore f of z is continuous at vector radius or radius vector also. Therefore f of z is continuous at every point or at origin. At origin. That is nothing but limit limit z tends to 0, f of z equal to f of 0 equal to 0. That is f of z naught. Okay, here z naught is origin. Next we can prove that, to show that f of z satisfies Cauchy Riemann equations at origin. At origin. That is nothing but dou u by dou x at origin equal to dou v by dou y at origin. Dou u by dou y equal to minus dou v by dou x at origin. We can show that these two equations are satisfies the function f of z. Here first we can take u and v means here u of x comma y is equal to real part of z f of z, v of x comma y is equal to imaginary part of f of z. First we can take f of z, that is x cube into 1 plus I minus y cube into 1 minus I by x square plus y square. Here first write the real parts, that is x cube minus y cube by, write the denominator part separately. Next plus I is taking common, this is x cube minus into minus plus y cube by x square plus y square. clearly u of x comma y is equal to x cube minus y cube by x square plus y square. U of v of x comma y by y equal to x cube plus y cube by x square plus y square. Here dou u by dou x first we can find out. First we can take u of x comma 0, that is y variable is 0. Why? Because dou u by dou x at origin means limit x tends to 0 u of x comma 0 minus u of 0 comma 0 by x minus 0, that is x. Next, dou u by dou y at origin means limit y tends to 0 u of 0 comma y minus u of 0 comma 0 by y. Dou v by dou x equal to limit x tends to 0 at origin means v of x comma 0 minus v of 0 comma 0 by x. Dou v by dou y at origin means limit y tends to 0 v of 0 comma y minus v of 0 comma 0 by y. In this, the partial derivatives means at origin the definition is limit x tends to 0 u of x comma 0. In this, the u function is differentiating with respect to x means y is treating as a constant and these derivatives are taking at origin. Okay, so in that case y is 0. Here first we can calculate u of x comma 0 means in the place of y 0 we are getting x cube by x square, this is x. Next, u of y comma 0 it is equal to x terms will be 0, that is minus y cube by y square, it is equal to minus y. U of 0 comma 0 means it's clearly 0 only. Okay, the same way v of x comma 0 means x cube by x square, this is equal to x. V of 0 comma y 0 comma y equal to y cube by y square, it is equal to y. V of 0 comma 0 equal to 0 only. Here u of 0 comma y equal to minus y cube by y square, it is minus y. Now here taking the values, limit x tends to 0 u of x comma 0 is x. X minus 0 by x, x get cancelled, it is equal to 1. That is limit x tends to 0, 1 is equal to 1 only. Okay, here limit y tends to 0, u of 0 comma y is minus y minus 0 by y, it is equal to minus 1. Limit x tends to 0, v of x comma 0 is x minus 0 by x, it is equal to 1. Why? Because x into x, x by x, it will become 1. Limit x tends to 0, constant is constant only. Then 0 comma y means it is y minus 0, limit y tends to 0, y minus 0 by y, it is equal to 1. Here clearly therefore dou u by dou x at origin is equal to dou u by dou x at origin is 1, that is equal to dou v by dou y at origin, that is dou v by dou y, this is also equal to 1. And dou u by dou y at origin, that is equal to minus 1. This minus in the place of 1 dou v by dou x at origin. Therefore, f of z satisfies Cauchy Riemann equations at origin. Okay. Now we can prove that therefore f of z is continuous and satisfies Cauchy Riemann equations at origin. Next, to prove that f dash of 0 does not exist, that is nothing but the derivative f dash of 0 is equal to limit z tends to 0 f of z minus f of 0 by z only. Here f of z is equal to u plus iv, that is equal to x cube minus y cube limit z tends to 0, that is nothing but x tends to 0, y tends to 0, x cube minus y cube by x square plus y square plus I into x cube plus y cube. Z is nothing but x plus iy. F of z is equal to u of x comma y plus v of x comma y. For two cases, the limit value is 0. Take x tends to 0, y tends to 0 and y tends to 0, x tends to 0. In these two cases, limit z tends to 0, f of z is equal to f of z minus f of 0 by z, that is equal to limit x tends to 0, y tends to 0, f of z is x cube minus y cube plus I into x cube plus y cube by x square plus y square to x plus I1. That is nothing but in the two cases we can take applying x is 0, then y terms will be there. After y is 0, then we are getting it is simply equal to 0. Already we proved in the previous case, that is continuous case. And limit y tends to 0, x tends to 0, it is also x cube minus y cube plus I into x cube plus y cube by x square plus y square to x plus iy is equal to 0. Take x tends to 0 and y equal to mx path. Then limit z tends to 0, f of z by z f of z minus f of 0 by z is equal to limit x tends to 0, substitute x cube minus m cube x cube plus I into x cube plus m cube x cube by x square plus m square x square into x plus I mx. Here in the numerator taking common x cube, limit x square x tends to 0, x cube into 1 minus m cube plus I into 1 plus m cube by x cube common 1 plus m square into 1 plus im. X cube get cancelled. So it is equal to 1 minus m cube into m cube plus I into 1 plus m cube by 1 plus m square into 1 plus im. The limit value here, the limit f of z is depends on m. Here if we take m is any value, then the limit of f of z is changes. Therefore f dash of 0 does not exist. F dash of 0 does not exist. Okay, at origin it's okay, but for along the path means that is a radius vector. In the radius vector, the limit of function or the derivative of function at origin is depends on m. Here m values are changes, then the limit value is changes. That is nothing but the derivative values are different in different cases. So it's not exist at origin. That is f dash of 0 is does not exist. So the function f of z is a continuous function and it satisfies the Cauchy Riemann equations, but it is does not exist. That is nothing but f dash of 0 is does not exist. Okay. If you like this video, please subscribe my channel and share to your friends.